All right, welcome everyone to today's NLP workshop brought to you by DSC. So today's workshop is going to be all about machine learning and in particular its application to the realms of natural language processing, right? So let me give you guys a quick introduction. So my name is Jishnu and I'm a tech associate in the internal team of DSC. And I'll be conducting this workshop alongside a good friend and co-host, Brian. Yeah. So, and you'll be seeing more of Brian later on in the second part of the workshop as he takes over from me. But for now, I'll start with a bit of a background about the club, right? So our aim is to, get people excited about technology, to share our passion with them, and to also help them get equipped with the relevant skills and industry insights. And so in line with that, we have this series of workshops. And as Senang told us earlier, this is the fourth workshop in the series. And we've had previous workshops on topics like machine learning and cloud computing and building your own portfolio website. So plenty of exciting stuff for you guys to check out on our YouTube channel. I'll be sharing the link later on in the end as well, or you can always scan the QR code. And so for the next slide, I'll just go through the contents of this workshop very quickly. So we have the tools of the trade first. So I'll be telling you guys, what are the tools we're going to be using in this workshop and how to use them as well. And then we're going to get into classification models. These are types of machine learning models that we're going to be using later on in the natural language processing element of the workshop. So it's very important to get the fundamentals right, and that's what I'll be trying to help you guys get to in the first part of the workshop, right? So following that, we'll have a quick Q&A and a quiz segment with attractive prizes to be won. So I hope you guys are all excited. And once that is done, we're going to get into the next part of the workshop, which is the natural language processing element, right? So we have some very exciting data sets over here. So we're going to be looking at things like what is the best restaurant around NUS and how does Instagram identify and tag COVID-19 posts, right? That is actually the topic of our little contest that we're going to have at the end. And again, attractive prizes to be won for the winners of that contest. So these are all actually real life examples and real life data sets that we have gathered over time. So we're very excited to share it with you guys and to let you guys immerse yourself in this world of machine learning and natural language processing. So without further ado, let's get started with the first one. The QR code on this page is for the Slido link. Slido is a question and answer platform that we're going to be using throughout the course of this workshop. And if you guys have any questions at any point in time, you can just head over to the link and submit your questions. And we'll be answering them as and when we see them or at our Q&A segments that we have at different parts of the workshop, at different parts of the workshop. So. And the second and arguably most important tool that we're going to be using is the Google Colab IDE. So IDE, for those of you who are unfamiliar, is a integrated development environment. So it is where people who write code write their code, right? So if if you click on the link over here, I will show it to you guys. Sorry, 1 second. Okay, apologies, give me 1 second. Okay, so if you click on the link over here, it'll take you guys to an integrated development environment by Google. It's called the Google Collaboratory, and it is a free-for-all browser-based development environment where coders write their code. And it is actually optimized for data science and machine learning, as you can see over here. So it's very suitable for our workshop today. And it's also used by, it's also powered by Google's own GPUs, right? So we're not going to be using a lot of our own device over here. We're going to be using the compute power from Google, and that's going to help us a lot in this workshop. So I'm very excited to share with you guys about this, and let's get back to the slides right now. So there we go. And the next tool we're going to be using is the scikit-learn code library. Scikit-learn, for those of you who may not be familiar with it, is a library that has hundreds of thousands of machine learning models in it. Now, these are long lines of code that help us implement the different machine learning algorithms that scientists have been working on for a very long time, essentially. And we're going to be using these algorithms in our workshop. We're not going to be writing our own ones because that's going to take us very, very long. But the most important part is to really understand how these models work, right? And to understand the implementation. And that's what we plan to do in this workshop. So those are the tools for today's workshop. And now we're going to get started with the basics of machine learning. So some FAQ at the start. What is machine learning? So machine learning, it is the science of developing algorithms that can imitate human learning methods. And what does that mean, right? So it's important to understand this in the context of machine learning versus artificial intelligence, because you hear those two words almost used like interchangeably, and it gets quite confusing. But machine learning is actually a subset of artificial intelligence. So artificial intelligence is a broad science of mimicking human abilities, and it goes well beyond just human learning methods, right? So a good example would be these two here. So your Netflix recommendations or Spotify recommendations, those will fall under examples of machine learning. And whereas if you have things like the Tesla bot, they will fall under artificial intelligence because they do so much more than just learn things in a linear pattern. So that's an important distinction to make between machine learning and artificial intelligence. And now we're going to get into what are the different types of machine learning models, right? So I have listed 4 of them over here. We've got the regression models, the classification models, the reinforcement learning, and neural networks. Now, these are like some of the more commonly used and easier to understand kind of models, but there are many, many more models. And actually, even within these 4 models that are listed over here, they're just like sort of umbrella groups of different types of machine learning models within them. So let's take a deeper look at this, right? So let's go into classification model, because that is the one that we're going to be using primarily in the later part of this workshop. So again, there are different types of classification model workshops in particular. And we have k-nearest neighbor, we have the support vector machines, Conor SVM, where the SVM stands for support vector machines. So it's a slightly different implementation of the same algorithm. And then we have things like naive Bayes and many, many others, right? So the ones in bold are the ones that we're going to be taking a look at later on. And we're going to get started with the support vector machine model in a bit. But let me just tell you guys quickly about what qualifies as a classification model, right? So classification models, the key thing to note about them is that they require your output to be classifiable or categorical in nature, meaning you must be able to put them into classes or labels. So if you're talking about things like test scores or BMI or your weight, those are things that are numerical in nature, and you can't really fit them into classes because they range from like 0 all the way to like whichever value out there. So that is a more continuous sort of quantitative data, and that is not ideal for classification models. So classification model, the model actually assigns each input and output class based on different criteria. And what does different criteria mean over here, right? So different criteria is actually the different implementations or the different algorithms that we're going to be using within classification models themselves. So like I mentioned earlier, these are the different types, right? So each of them will have their own implementation or their own algorithm that they're based on. And that's what different criteria basically means. So let's take a look at an example, right? Because that's the best way to learn things. So you want to create a machine learning model that can help you differentiate between green apples and lemons. It's not a particularly useful model or practical model, but it's a good example. So we're going to be taking a look at this. And for humans, it's very simple, right? You just look at it and it's an apple, it's a lemon. But the art of machine learning is to try and understand how a machine will be able to make this same distinction as humans do. So we're going to be taking a look at the SVM model that makes this differentiation. So I've plotted a graph over here of texture against shape. Sorry about the letter E over there. But we have all our data points in this graph, and it's the best way to visualize, not just your data points, but also the way in which your model is being implemented, right? So if we take a look over here, we have our apples in one corner of the graph, and we have our lemons on the other corner of the graph. And so they're divided by these two categories of texture and shape. But then we have these two sort of data points over here that are identified as being support vectors. And what does this mean, right? So we have what is over here is we call it the most lemon-like apple, because it's further away from any of these other apples, and it's also the closest to this group of lemons over here. So it's the most lemon-like apple. And then we have something else over here, which is the most apple-like lemon, perhaps. So these are two data points that are stray very far away from the sort of average of their group, but they're still categorized as being lemons or apples. And the idea here is that if your model is able to successfully distinguish between these two items over here as being apples or lemons, then it should have no difficulty distinguishing any of these other items, right? Because if you can tell what is the most confusing item is, then you should be able to tell, much more clearer examples of apples and much more clearer examples of lemons. So the model uses these 2 points over here as sort of coordinates or vectors. That's why they call support vectors, right? And it finds a midpoint between them somewhere around here, perhaps. Sorry about the drawing. And it draws a split, a linear split, if you will. And subsequently, any other data point that falls over here, something new over here, or like something new over here, you'll be able to classify them as, being apples or being lemons. So anything on this side of the line will be classified as apples, and anything on this side will be classified as lemons, right? So this is, in a nutshell, the very simple implementation of a machine learning model, basically a support vector machine model in particular. And now we're going to go on to a bit more, a different example or a different implementation. And this is for the Conor SVM over here, right? So Conor SVM is a bit different, and it is more powerful in a certain way. So let's look at this data set where things are not so linear, right? Over here, we had, in the past slide, we had a very clear split between apples and lemons. And over here, it's clear, but it's not as linear as we would like it to be. So how do we deal with non-linear data sets? Well, the trick is to use the kernel trick. And this is what actually lends the model its name, right? The Conor SVM. And the Conor SVM maps the data over to a higher dimension where a linear split can be made. What does this mean, right? So let me give you guys a quick example over here. So let's say we have these 2 graphs over here, right? And we have one of y against x and y against x squared. Now, if you try and plot a graph of y equal to x squared on this axis, it's going to look something like this. But if you plot it against something like a y against x squared graph, it's going to look much more linear. And this is a similar concept to what this machine learning model applies, right? So it tries to find a dimension in which you can make a linear split. And once you can make that linear split, it is much more easier for you to classify your items as belonging to either category. And so let's take a look at this example here, where we have mapped it over to a different dimension, where we have this linear split that is very conveniently drawn for us, right? And subsequently, again, you can classify anything that falls on this side of the line as being a lemon, and anything on this side of the line as being an apple. And hopefully, chances are you're going to be correct. And so again, this is the fundamental logic of Conor SVM models. And we've taken a look at these 2 models, but what's exciting is we're going to now look at a real implementation, right? So far, we've just been looking at models and diagrams. Now we're going to take a look at the real code and how this is actually implemented. So again, here's a new example for you guys. Imagine you're a data analyst working at Apple. You have been asked to analyze the probability of a customer purchasing the newest iPhone, given just these 2 data over here, so their age and their estimated salary. So I have a short excerpt from the data set over here. The actual data set is much bigger. But so we have a person of age 19 and estimated salary 19,000, which is a bit odd. It's quite high. Maybe invested wisely in crypto. I don't know. But so he didn't purchase the iPhone though. So this is an example of our data set, right? Now we're going to take a look at the real implementation of the data set. So let me just stop sharing and get back to you guys. And so hopefully you guys can see the screen now. And Brian will be sending you guys a link to the Google Docs that we have shared and prepared for you guys. So we have a Google Drive where we have prepared all these the slides for this workshop, and also different data sets and the different collab files that we're going to be using. So I think Brian's already sent the link and you guys can open it. So I believe once you guys open it, you'll be led to this folder over here called participants. So what I need you guys to do now is, once you're in the folder, right, just click on the Conor SVM implementation. So that's the one that we're going to take a look at first. And you can see all these files over here. This is the file that you guys need to open. So just double click on it and it will lead you to this page. So I'll just give you guys a quick couple of seconds to do that. If you have any questions, just send them over to the Slido link and Brian will be happy to assist you. Right. Okay, so hopefully everyone's got here without any trouble. And again, important thing is you don't need to download anything, you don't need to make any accounts or whatever. So as long as you have a Google account, you should be able to access all of this. And so you guys can actually will be able to run this and edit it on your side, but you won't be able to save the changes. But if you wish to save the changes or like save this file in general for future reference, you can always head over to File over here and save a copy in Drive or GitHub or any other tools that you guys prefer to use. So that is just for later. But for now, let's take a look at this implementation. So it might seem a bit intimidating or confusing at first, but I'm going to walk you guys through every step one by one, so we really know what's happening in this template and what's going on. So let's start right from the top. So I'm going to go through in detail so that people who are unfamiliar with CS will also be able to understand. So let's get started, right? So importing the libraries is the first step. So like I mentioned earlier, we're going to be using libraries of code. We're not just going to be writing our own code from scratch, because that's going to take very, very long. So we imported some libraries like NumPy and Pandas. These are libraries that are used for data analysis, data configuration, and also over here just to color our code and to make it a bit nicer or more visually appealing, right? So we've imported the libraries over here, and after that step, we have importing the data set. And these 3 lines of code, what it does is it reads the data file that we have uploaded over here, right? So you can download this CSV file onto your own device, and this is the import line where you're going to be importing the data. And we've imported it into this variable called dataset. And again, we have split that dataset into the X variables and the Y variables. So this is going to be coming in handy later. And I'll show you guys just how to import the dataset, right? So on your device, if you wish to experiment later on, you can download this dataset over here and head over to the same collab page and click on this little folder icon to your left, and it will connect you to a runtime to enable browsing. So what is a runtime, right? A runtime is a sort of active session, if you will, so that activates the Google server so that you can actually perform any running of the code. And once you open this file and get into a runtime, you can click on this little file icon, and it will prompt you guys to upload the data set. So you can move over to the data set over here, and I've actually uploaded it over here. So it's called purchase-data.csv, and once you click OK, you should be seeing it over here. So you guys can follow along with this workshop, or you can always look at the recording later on in YouTube, or even look at the slides and follow us. So this is just for a demonstration, right? So I've uploaded a file over here, and it's been imported now. So the next step is to split the data set into training set and test set. What is training set and what is test set, right? So this might be a bit confusing, but training set and test set, basically what they are is, let's take a look over here. So training set is a set of data points that your machine learning model is being trained on. And your test set is the actual data set that your machine learning model will be tested on. So, and then in the middle, we have this thing called the validation set. So training set and validation set, these fall under your development stage of the machine learning model. So initially, you give it a very large training set of data to train your machine learning model to be as accurate as possible. And then as part of the development process, you will have a validation set of data that you will use for a preliminary test to see if you can improve your model on any scale or any metric. And once you've done that and you actually publish your machine learning model for use, it's going to be tested on what is known as a test set. And this is the actual data set that your machine learning model will be tested on. But for today's workshop, we're just going to be using the training set and the test set just for the sake of time and for convenience. So here we have made the split between the training set and the test set. You can notice that the test size is 0.25, meaning we have taken 25% of the data for the test set and the rest is allocated to the training set. So once that is done, the last step of our sort of data cleaning process is feature scaling. So feature scaling is used to map our input data, which can range from 0 to 100 for age, or 0 to like some hundreds of thousands for salary, to a smaller range to enhance the accuracy of our model. And this is an especially important step for data set with multiple IVs of different magnitudes. IVs over here stands for independent variables. So things like your age, your salary are independent variables. And if you notice, the age is just a small number. It's just from 0 to 100, right? But then your salary is something like that goes from like thousands to hundreds of thousands. So you want to make sure that your model does not misconstrue your salary variable to be more important in any in any respect than compared to your age variable, right? So that's what this feature scaling process is doing over here. And it's very short code over here. If you guys are unfamiliar with it, that's all right, because our main purpose over here is to really understand the workings of the model rather than looking at the code and the semantics of the code in particular, right? So next step is to train the Conor SVM model on the training set. And this is one of the most important steps. So you want to make sure that your training set is being put into your model and your model is run on it. And that's what happens over here. So we're fitting the training set data separated into the X column and the Y column. And we've imported the SVC model from the scikit-learn library. And once this step is done, our model will be trained and ready for use. And that's what we've done over here. So far, all these steps have been about importing the data set, creating our machine learning model, and also cleaning the data. So once all that is done, our model is good to go and we're ready to use it. So here we have used it to predict a new result, and we've passed in just one data point. So a person of age 30 and with salary of 87,000, is the data point that we have passed into our classifier model. And you can see over here that the model has been run and the output is 0. So meaning the model predicts that the person has not purchased the iPhone, right? And this may or may not be correct, we don't know yet. But what we have done for the next step is, instead of just passing in one data point, remember the test set that we created earlier? Well, now we're going to be passing it into the trained machine learning model. And we've done some coloring so that you can see which predictions have been correct and which predictions are wrong. So if you look at the code over here, the one in the left column is all the predictions that our model has made. And the one in the right column is the actual test output, right? Sort of expected output, if you will. And looks like most of it is green. So that's good. We have like a couple of reds over here. But it's hard to tell, which one is the one that is going wrong, right? And that brings us to the next step. So far it's all good. We have very few mistakes, it seems like, so that's all right. And the next step, making the confusion matrix, right? Yeah, I'm not a robot. I think you guys might see this soon. So if you're not, as long as you're not a robot, just click on it. And you should be good to go. And making the confusion matrix, right? What's this? What's this weird set of numbers we have over here? Well, let me go through. So if we look over here, I've imported the same. I've taken a screenshot of this and pasted it over there. So we have these sets of 4 numbers over here. What do they mean, right? So firstly, 0.93 is the accuracy of our model. So meaning out of 100 data set or 100 data points that we have passed into our model, 93 of them have been written with a correct prediction. So that's actually very, very good when it comes to machine learning standards. And 64 over here is the number of true positives that our model has predicted. And 4 is the number of false positives, and so on. So a true positive, for those of you who are unfamiliar, is a case where our model predicts that something positive is going to happen, and the truth is that something positive did happen. So in the context of this example, it would be that the model predicted that this person is going to buy an iPhone, and the person did actually buy an iPhone, as we expected. So the ones in green are the positive or the correct examples that our model has predicted, and the ones in orange or red are the false ones. So over here, it's actually a very good machine learning model, because 93 is a very high number for most machine learning models. But okay, so far we have taken a look at the Conor SVM model and the SVM model, and we've taken a look at the implementation of a Conor SVM model. So so far, if you guys have any questions, you can head over to the Slido link and put up your questions over there. You can also vote for other people's questions if you guys have used Slido before. So if you see a question that you think needs to be answered urgently, you can always vote for it and we'll take a look at it. But let's go on to the next step now, right? So just before the Q&A segment, we're going to have one more model that we're going to be showing you guys. And this is the naive-based model. And now all three of these models will be coming in handy in the contest at the end of the workshop. So I hope you guys get to really understand how these models work before you actually use them. So again, we have the same data set, a nonlinear data set, and I plotted the graph over here. And step 1, plot the existing data. Step 2, add the new input data point to the plot. So we're going to be adding a new input data point, and there we go. Step 3, draw a circle of radius r around the new point. Okay, that seems quite random, but okay, let's draw it, right? And step 4, count the number of data points within the circle that fall under each output class. So let's take a look at this over here. So we have this circle, and we have 3 lemons inside the circle, 3, 9 green apples over here, so that's 9, and that gives us a total of 12 data points in the circle. So what's all this, right? So this is the key step to understanding how the naive Bayes model works, right? So it calculates the probability of the new input data point producing an output of either class. So it follows that logic of like, if this point is over here and a lot of it and a lot of its neighbors are apples, chances are it is going to be an apple as well. But if most of its neighbors are lemons, then chances are it is going to be a lemon as well. So that is the key logic that underpins this implementation. And so we have calculated the probability as being 25% and 75% respectively. So now you can sort of predict what is going to be step 6, right? So step 6 is to assign the predicted output to be the most likely or the most probable output based on the calculations in step 5. So most of these are apples over here. So the model is going to predict that any new data point over here within this circle is going to be an apple, right? So that is a naive Bayes model again in a nutshell. And but there's some very important things to note for this model in particular, right? So the first point, the machine learning model does not actually draw circles. It merely uses the distance between points and compares them with the radius of the circle. So the whole concept of a circle is just for our visualization. But in reality, we're going to have much more complex data sets with a lot more independent variables. So it's going to be like 5, 6, 7 different dimensions. So you're not going to be really seeing a circle anymore. But the idea is the same of calculating how close a certain data point is to its neighbors. And we're just going to be looking at a certain number of these data points. And that number of data points is determined by this radius r, right? So again, the magnitude of the radius can affect the values of the predictions. This is especially for more questionable inputs or complex data sets. So you have a data set that is like, in multiple dimensions and, with very like a wide variety of data points, it's going to be very complicated. So let's get into the Q&A segment now. So that is, so far we've covered 3 different models, right? So we have the naive Bayes model, we have the SVM model, and we have the Conor SVM model. So if you guys have any questions, send over to Slido. I'll give you guys maybe a couple of seconds to see if we get any questions. If not, we'll be getting into the quiz afterwards. So it'll be good to clarify your questions before that, so that you can win the prizes. Okay, so I think we have a question. Does the Conor SVM model use linear algebra or something? So let me take you guys to the scikit-learn page itself, right? So this is the page where we're going to be taking all our models from. So far, we've only looked at classification models, but there are many other models out there. Let's take a look at classification, right? So as you can see, there's like so many of these models over there. So let's take a look at support vector machines and kernel. So you can see over here that there's some of the implementation of the code and some, a bit more detail of like the mathematical formulation or just the mathematical logic behind some of these codes and some of these algorithms. So you can, if you're going to get into the actual math, I'll probably need a couple of years to get a math degree first before I can start talking to you guys about all of this. But feel free to check out this website. I'll be sending the link in the slides later on. So yeah, it's very exciting. There's like hundreds of thousands of machine learning models, and each of them has their own unique concept of understanding classification and regression and all these other different types of models, right? So yeah. If you have any more questions, always send them in. Okay, we have another question on the naive Bayes model in particular, right? So how does that work, right? So it is fundamentally the concept of calculating the distance between 2 data points. So for us, I mean, you might have heard of it in the simplest ways of being, the I forgot the name, the Cartesian coordinate system, right? So you just have, the square root of the x and y, and the square root of the square of the distance between the points on the x-axis and the y-axis, and so on. But we have multiple different types of naive Bayes models themselves. So we have the Gaussian one, the multinomial, the complement, Bernoulli, and a couple of others, right? So each of them has their different sort of formula or algorithm for calculating this distance between data points. But fundamentally, the concept is that they look at their closest set of data points within a certain range of distance, right? So maybe in the 2D diagram, we can visualize it as being just a circle with a radius of r. And so the radius is the limiting point that determines the range of the data points that we're considering. But if we go into like different dimensions, that value might change. We're not going to be looking at maybe something like radius, but we're going to be looking at whatever belongs to the fourth or fifth dimension and beyond. So yeah, again, if you're interested in the math, you can always check out the scikit-learn library and read further, because it's very complicated, but it's also very interesting. Right. Which classification model is the best? That is actually sort of the idea of our contest at the end of the workshop. So if you stick around to the end, we have a bit of a treat for you guys, I guess. It's going to be using a real life data set and some of these models that we have seen just now. So that's going to be very exciting. But for now, I think we're running out of time. So I'm going to move on to the quiz, right? So Kahoot quiz. I hope you guys are excited. I'm going to pass over the sharing to Brian so that he can share you guys the link to the Kahoot quiz. Just give us a second while we set it up. All right, so you guys should be able to see on the screen the QR code and the game pin for the Kahoot link. Once you guys are ready, you can join the link using the QR code or the link or the game pin, sorry. Yes. We have one participant so far. We have two participants. All right, so the prizes to be won for the first place in the quiz and the first place in the contest. So I hope you guys are excited and manage to win something, because that's going to be fun. All right, we'll give you guys a couple more seconds to join in, and soon we'll get started. All right, maybe about 10 more seconds. Okay, I think we're good to go. What is machine learning? I think that was the first question that we went through. It's also the FAQ, so I really hope everyone gets this right. Okay, yeah. So most of you got it right. Two of you think it's about enabling machines to make their own decisions. It's actually not too far off. I mean, I'm sure some people are working on it out there, but fundamentally, machine learning is about developing algorithms that can imitate human learning methods, right? So on to the next question. Okay, very close. Which of the following are not machine learning models? I think we had a slide on this as well. So send in your answers once you're ready. I think the fastest fingers gets the most points, right? As long as you get it correct. So yeah, okay, that's good. Most of you got it correct. So neural networks is actually, it is a type of machine learning model, but we're not going to be covering it because I think that was actually a content of a previous workshop. So if you guys are interested in that, you can always check out the YouTube link. Okay, next question. All right, ZY is. really pulling a lead of 2 points. Which of these is a classification model? So is it the hierarchical clustering model? Is it the support vector machine model, the multiple linear regression model, or the support vector regression model? The name might be a hint. All right, good. So everyone got it correct. That's great. So next question. Ooh, that's a very tight battle. Which model is best for nonlinear data sets? Ah, okay. So a couple of you, actually quite a few of you, think it's the naive-Bayes model, but it's actually the Conor SVM model is optimized in particular uh, uh, for nonlinear data sets. But naive-Bayes models can be accurate as well. So it really depends on the particular data set and the particular context in which you're using all these models, right? So that is going to come in handy. That point is going to come in handy in the contest. So keep that in mind, right? And let's go to the next question. Still a very close battle. For classification learning models, are the outputs continuous or grouped into class labels? Again, I think this was at the start of the workshop. So yeah, so it should be classified into groups or class labels, right? So that's what lends it the name classification models. So next question. Someone's on a winning streak. Is not true about a confusion matrix. Not true. So is it a summary of prediction results? Is it true that it confuses people? It consists of 2 rows and 2 columns. It contains both predicted and actual values. So which of these is not true? Yeah, so it's not true that it confuses people, right? I mean, maybe at the start, but once you really understand what it's about, it's a very useful tool for understanding your model's accuracy. So next question. Who is the organizer behind today's workshop? I hope everyone gets this right. I'll be quite disappointed if some other option becomes the highest. All right, great. So no one's going home sad today. All right, so it's the Google Developer Students Fund. So let's take a look at the podium. In third place, Ish. In second place, we have Python. And the winner, okay, I guess it's Imagine Losing. He didn't, but he actually won. So imagine losing, whoever you are, send us your email address later on in the Zoom chat or through in Telegram, and we'll send you guys the presents or the prizes later on. So that is the Kahoot quiz settled. So let's now go on to the next element of the workshop, the natural language processing. And now I'm going to pass over the time to Brian, who's going to take over from me and tell you guys all about natural language processing.
Okay, hello everyone. So I'm Brian. I'll be conducting this section on natural language processing. So this section will be more interactive. If you recall the Google Colab earlier, you actually get to use it and join me in determining what is the best restaurant around NUS. So we've actually gathered some, Google reviews of some familiar restaurants, I'm sure, especially for those of you that stay on campus. And we'll go here and look at which we'll use our natural language processing model to analyze the reviews and determine whether it's a positive or negative one. Following that, we'll have the COVID-19 data set. So if you've ever wondered how Instagram puts up the COVID-19 tag, the one that says, for more COVID-19 information, you can visit gov.sg, and we'll let you figure out, we'll let you even build the model and learn how it's done later on in the workshop. And I'm sure all of you will be able to do it later on. But first, you have to bear with me for a bit. I'll give you some background on natural language processing. So let's begin. What is natural language processing and how is it used? Natural language processing is about enabling our machines to understand and generate human language in the same way that I'm talking to you through Zoom right now. In the same way that you read a book, in the same way that you can read the chat in Zoom, it enables our machines to understand these words and make sense of them. And where is NLP used? You'll find that NLP is used commonly in our daily lives. And many of these brands, I'm sure, look very familiar to you, right? I'm sure everyone has seen all of these brands before, the Grammarly ads on YouTube. Any iPhone user would know of Siri, and of course, Google Translate, famously wrong, often gives you some weird translations sometimes. But what we'll be focusing on today is the classical learning model. And so what is the classical learning model? The classical learning model uses basic machine learning models such as classification, which Jishnu has covered earlier, as well as regression in certain cases, to analyze and interpret text. And they're actually trained on large data sets of human language, and they actually interpret data differently from us. Let's take a look at how they interpret it. So I actually have a review I took off NUS Mods for you guys to take a look at. So let's say we are designing a model to determine whether a review on NUS Mods is positive or negative. How exactly would the machine look at it? So I'm sure this mod will be familiar for some of you. I'm not going to say the name of this module, but just from the review, I'm sure some of you can guess what this mod is going to be. So what our model actually looks at is these few keywords. And what exactly do we do is these few keywords? We actually put them into this bag of words model. So this bag of words model is a bag of 20,000 zeros. And each zero represents a word in the human language, as you can see at the bottom of my screen. So why 20,000, right? What's so special about this number 20,000? Well, 20,000 is often quoted as the average number of words an English speaker has in their vocabulary. So it is to account for all the possible words that you may see in some text. So, for example, when in our previous NUS mods review example, for these specific words that we have highlighted, when these words are seen, we actually increase the count in this bag. And so you can see that we have increased useful to a count of 1, as well as tips to a count of 1. And by counting the number of positive versus negative words that appear, we can actually determine whether the review is positive or negative. So in this example, we have, let's say we have this example of the words useful of times 1, tips times 1, and difficult times 1. So our model will determine it to be 2 positive and 1 negative, and hence it's evaluated to be a net positive. So what we'll be looking at today, these are some of the restaurants around NUS that we will be looking at today. I'm sure they look familiar to some of you. Pasta Express, at Frontier, Aman's at Supper Stretch. And we'll be analyzing the Google reviews for this restaurant and determining whether it's positive or negative. So I have 2 examples for you guys here. Example sentence 1, it was the best meal I ever had. And what our bag of words model will do is increment each word and realize that best is actually a positive attribute. And so you will read this sentence as a positive one, versus sentence 2, where it was the worst meal I ever had. And you will thus be rated as a negative one in this case. So I hope I hope you are following along. If you have any questions, you can of course drop us a Q&A in Slido and we'll answer it. Jishnu will answer it. Yeah, and so Jishnu will go ahead and send the link to the Google Drive, the same link as before, and I'll show you guys where to access it. So, so if you can see this link here under participants, we can go to the restaurant reviews section, which we'll be doing today. And I'll just go through the data set that we have for today. We actually gathered 24 real reviews from 5 different NUS restaurants that you can see here. And these are actually real. If you Google them, you can actually see them. And yeah, some of them are positive, some of them are negative, and we'll see how our model fares when it comes to determining whether these reviews are positive or negative. So you can see this 24 reviews. This will be the test set. Now, what exactly will be our training set in this case? If you take a look at this NUS restaurant reviews data set that we'll be using, you can actually notice that there's a lot of data here. And the first 900, there's a total of 1,000 entries. And the first 900 plus entries, actually, me and Jishnu, we got it online. We got it online to train our model in order to determine the reviews for these restaurants around NUS. So of course, the first 900 plus is not from restaurants around NUS, but we use it to train the model so that it can understand better restaurant reviews for these NUS restaurants. Yeah, so now let's get right into it. You guys will be following along here. So what I'll need you guys to do is open up NLP for NUS restaurant reviews. So it will open up as a Google Colab. Once again, you do not need to download anything. But what I will need you guys to download actually is our data set, which is this NUS restaurant reviews.tsv. So I already have this file downloaded and I'll be using it later. But if you do download it, it should be in your download section if you use Windows. I'm not too sure about Mac because I don't use Mac. But yeah, go ahead and download it, and we'll give you guys some time to open up the Colab as well as download this specific file, this TSV file. Do let us know if there's any technical issues, you can't find a file, or if there's anything. Yeah, so it seems that nobody has any issues so far. So if you'd like to make a copy of this, once again, you can go ahead, click on File, and save a copy in your own drive if you would like. Otherwise, you can run it here if you would wish to. It's fully online, no need to import it into your Google Drive. So what we'll need you to do first is to click on this folder icon at the left side. So if I may direct your attention here, this folder icon, and what we'll need you to do is to drag and drop the file that you're using into this box here and press OK. So this is the file that we'll be working with for today. Reminder, it is 900 plus training entries as well as actually 24 real reviews around NUS restaurants. Yeah, so I hope that everyone's following along. So we'll start by importing the libraries. As Jishnu has gone through earlier, these libraries are used for data analysis. So, of course, this workshop is not meant to be too technical. We won't go into too much detail on what these libraries do. But if you're interested, once again, you can go ahead and read more about them on Scikit. And we actually send the link out later on. Yeah, so we'll start by importing the data set. This basically enables our machine to read the data. So if you're following along, just press the play looking button, the run cell button for each section. And yeah, you'll run as per proper. So I hope everyone has ran the first two because we need to go in order. Next up, and this is the main bit, we'll be cleaning the text, and I'll show you exactly what this means later. So I know, especially for students without any sort of programming background, this looks like a huge mess of words, right? Yeah, and we won't go into the nitty-gritty of it, but we'll show you what exactly happens when you clean out the words. And so we remove stop words, we remove the we change the words to the base form as well as lowercase. So actually, we actually included this print statement for you to take a look at what actually happens when you clean out the words. So let me show you an example here. So let's go back to our restaurant example. Let's say the second review. If you can't see, it says the ambience was wanderlust and relaxing, and the service was great. And if you look at the clean version, it says ambience, wanderlust, relax, service, and great. So as you can see, it has cleaned out the unnecessary words that we do not need, like the, was, great, to, for example. And if you like to go into more, you can see how it has cleaned out all 24 entries for NUS reviews. Yep. So yeah, so we have now already cleaned out the keywords. Now we'll be creating the bag of words model. And I'd like to direct your attention back to the bag of words model. We have 20,000 zeros, and every time each word appears in this review, we increase them so that we can determine whether it's a positive or negative review. So yeah, just go ahead and press the run cell button whenever you're up to this stage. I'll give about 30 seconds. Do let us know if there's any issues. Yeah, while it may look like a jumble of code now, we'll definitely show you guys what it looks like as a result later on. Okay, I hope everyone has followed up to this point. So the next stage actually is to split the data set into the training and test set. And that is where you amend this test size number. So remember our 24 reviews out of 1,000 reviews are from NUS ones. And that's what we'll be testing. The other 900 plus is a training set, is to let our model know what restaurant reviews look like, what a positive review looks like, what a negative review looks like. So what you got to do is press run here, you'll split it. And then the next segment will train our naive-based model on the training set. Yeah, so as you can see, Google Colab is quite straightforward. Just press the run button whenever you're ready. And now to the essential part, which is predicting the test set results. And so we have actually colored it for you. You can go ahead and press the run button anytime. So if you can see that it's in the green color, it means that it was a successful prediction. So a 1 is a positive prediction. So as you can see, it corresponds to each of these reviews. So for example, this is a positive review, right? Good food, good ambience, tasty, authentic. And yeah, the right side is what the model predicted. So yes, it was a positive review and successfully predicted as positive. So let me point your attention to the third review now. It was a negative review. And the model has successfully predicted it as a negative review. Now, of course, our model isn't perfect, and you can see here that the 7th review was not successfully predicted. Let me show you an example here, which should be this one. There seems to be a minor change in the decor since our last visit, but overall offers a functional but cozy enough setting. So as you can see, our model predicted this as a positive review when it was actually a negative one, although this is kind of a on the fence review, and this is where our model can fall short. And I'll go into more into depth about that later. Yeah, so and finally, you can make the confusion matrix. For those that don't remember what the confusion matrix is, that Jishnu went through earlier, it is basically to group it into the true positive and the true negative, which means correct versus wrong predictions. So the top left and the bottom right are the correct predictions, and vice versa for the wrong ones. And as you can see in this example, it is quite successful. We have a 96% accuracy in predicting the positivity of a review. Of course, this is partly because we have such a huge data set. You'll see later on in our COVID-19 section that it's not always the case that the prediction rate is so high. And sometimes even a success rate of 60% is considered relatively high. So I hope that everyone had fun understanding how, how we use this model to predict whether these reviews are positive or negative. And based on the predictions, of course, as you can see, Pasta Express is predicted to be the best restaurant around NUS based on our model. So if you're thinking about where to go for lunch tomorrow, you could consider Pasta Express, I suppose. Okay, so but of course there are always downsides to every model, and we'll go into that now, as well as some alternative models. So for example, something that we would like to touch on lightly is deep NLP. So this stands for deep natural language processing. And instead of supervising our model to learn like what we have done, we enable it to learn similar to how we learn. The deep NLP is kind of a relatively new thing, and is a new advancement in AI. that allows our new models to learn unsupervised. So here's an example of what you can do. Let's say we have a CAPTCHA that you will see when buying things online, or an ebook, or even a street sign. And of course, the deep NLP model will be able to interpret it as for what it is, instead of needing the strict words. Even in different formats, you can interpret it as what it is. Something else that we'd like to point out that is quite relevant actually, and is something that's still in development, is Google's BERT. So it stands for bidirectional encoder representations from transformers, which is quite a handful to say. And it's the latest breakthrough in NLP, and it will actually affect Google search. So you will consider the context of a word rather than individual words. Let me show you an example here. So for example, let's say you Google, this is currently now, you Google 2019 Brazil traveler to USA need a visa. And previously it showed you, a Washington Post article. But after that, you will consider the full context of the sentence and realize that what we want to look at actually is what we actually want to look for is actually how to apply for a visa. Furthermore, we have this, can you get medicine for someone pharmacy? Let's say you search that, and you will actually realize that instead of searching for how to get medicine for someone, is actually understanding that you are searching for whether it is legal, whether it is morally right to get medicine for someone else, whether it's within the bounds of the law, and it'll show you the appropriate search instead. And finally, do estheticians stand alone at work? Previously, they'll compare, this medical esthetician versus spa esthetician. But now you understand the context of the sentence, that you're asking about the physical demands of the job, and you'll recommend you accordingly. Yep. So if you'd like to read more about it, you can read more about it here. And yeah, and now I'd like to continue on to the part that I missed earlier, which is the disadvantages of our NLP model that we just went through. So of course, one might argue that a better way to represent the quality of a restaurant is 1 to 5 star reviews that you see on Google. But unfortunately, a binary output that we have in our classical learning model only allows good or bad. So it only allows true or false, good or bad, this kind of 2 output outcomes. And we can't display a wider range of outputs. And it can lead to some inaccuracies, like the example we had earlier, where this example where it was a misprediction, where it has some neutral language. There seems to be a minor change. Overall, still functional but cozy enough. But there was a letdown in the service, where it's a neutral, semi-neutral rating. So it might be a 3-star review, for example, that we cannot see reflected here. And another disadvantage is that you cannot consider the context of a text. So actually, let me give you another example here, and I'll bring up our favorite NUS mods again. And this time is actually a sarcastic review. So I believe we have a Slido question about it, and we actually talk about it here. So some of you may be able to guess which mod this is. Yeah, and of course, clearly you can see through the commenters' use of words such as pinnacle, calling your education complete after you have spent a week of your life answering 300 questions on Luminous. I think a human might easily tell that this is a sarcastic review. But as far as our model is concerned, it's a positive review because it has the words pinnacle, education complete, and so on. So yeah, the model does fall short in certain areas. Now, finally, we'll have a Q&A section. So if there's any questions you have about this NLP section, how to run collab, about our data set, you can ask us in further detail here. You can drop questions through Slido and we'll answer them.
Yeah, so in meanwhile, while we wait for any questions to come in, just to add on the example of sarcasm, right? So how does it all work? So for classification models, that is a key weakness, because if you classify a phrase that has positive words in it as being sarcastic, and then you tell the model to label it as being negative, then that is a huge contradiction for the model. So you're gonna end up losing the accuracy of the model, and unless you're going to go through a lot of sarcastic comments, that is not a useful way to train your model, right? So that's where all these other different models come in. So we have things like your regression model. We have things as complex as the Google's BERT that Brian mentioned. So it's about understanding the context in which these words are presented. And that may be hard or that may be easy depending on where you get your data from, right? So if we're just taking these like text out of, sort of text only places, like maybe Reddit or whatever, then it might be a bit hard for you to understand the context. But then if you go at things like Instagram, maybe you have a picture associated with it, then that might make things a bit easier. So for a model to then understand the context, right? But then you need much more complex machine learning algorithms. You're not just going to be relying on things like natural language processing. You're going to be relying on things like image analysis and computer vision. And so that is where things will get more complicated, but at the same time more interesting. So yeah. There's another question over here. Is it possible to train a model to categorize into other things instead of positive, negative? Example, sarcastic, literal, or some other binary value. So that's actually a very good question. So when we're talking about binary output, it can be pretty much any kind of binary output, right? So as long as you're able to differentiate between those two classes yourself, then your machine learning model will have little to no trouble making the same differentiation, as long as you're able to then train it on a sufficiently large data set to get it to be really accurate at what it does. So things like differentiating between sarcasm and literacy, or binary values like maybe positive and negative, can easily be done. So yeah, I think there are no more questions on Slido. So, but again, if you have any questions at any point, just send them in, right? And I guess that brings us now to the last part of our workshop. And I'll take over from Brian now to share with you guys about the last contest. All right. Okay, so the last part of our workshop is about Tech for Good, right? And this is sort of our club's motto. And we're going to take a look at NLP's application in this context. So we're going to be looking in particular about how Instagram is able to identify COVID-19 related posts. I'm sure most of you must have seen this page on your homepage, right? On your feed, where we have posts that are tagged with the COVID-19 or COVID-19 vaccine related information. So our idea is to figure out how this model, how Instagram is able to do so, using NLP. Of course, like I mentioned earlier, things like images and image analysis are just as handy in making this differentiation and this classification. But in terms of NLP, we can look at the captions, we can look at text in the photo itself, and that's where NLP is going to come in handy. And this is a very good example because it's a clear example of classification problem, right? So we want to classify the post as being either COVID-19 related or COVID-19 unrelated. There isn't really a sort of like in between or any sort of quantitative data that we can gather from here. So it's a very good example of a categorical data that we can apply NLP on. In particular, NLP in a classification model, right? So this is the contest, and so we are going to explore 3 different machine learning models and analyze the accuracy in making the correct classifications on our test set of Instagram captions that Brian and I have gathered over time from Instagram, right? And this will not be a code long session. We're gonna give you guys the template. We're gonna give you guys the data set, and we want you guys to run these 3 different models and create a copy of the templates on your site, so you'll be able to run these models and edit and save them, right? And to get you guys started with it, I'll show you guys how to go about it, right? So once you go into your folder, I think Brian will be sending the link again for the Google Drive, or you can always scroll above and find it. So in the participants folder, there's the NLP contest folder, and we have these 3 different models over here. If you notice, they are the ones that we have gone through earlier in the workshop, right? So the SVM, the Conor SVM, and the naive base, and we have the data set over here. This is the format in which you guys can read it, and this is the data set that you guys can download and then subsequently upload into your models, right? So just to get you guys started, let me just open quickly one of these models over here. So let's take a look at the SVM model. And right, so it will be easier if you guys download this data set so that you can upload it faster into this code file. So if you notice over here, there is a text that is in green, and this is a little thing that we have added to every single file, right? So in every file, we have removed either a phrase or a line of code that contains an important element that is required for the whole code file to run seamlessly. So over here we have removed the file name. That is a pretty simple example. And once you guys add in the correct file name over here and upload your file and run, you'll be able to get the data or the correct figures at the bottom. And the winner of the contest is the person who comes back to us with the most accurate model and also the accuracy, the number that is gotten, right? So the decimal at the end of the confusion matrix. So the person who comes back to us with the highest figure, not the highest figure, sorry, who comes back to us with the result of what is his most accurate model is the winner of the contest. And again, there are prizes to be won over here. So you guys can get started, and we'll give you guys maybe about a couple of 5-10 minutes, and we'll see who comes back to us first. And at the same time, if you have any questions, you can always drop us a question in the Slido, and we will answer it. Or if you guys get stuck at any point as well, we can give you hints. We might, So yeah. So again, Brian and I will be on the Slido page if you guys have any questions. And again, go to the NLP contest folder, click on all these files, download your data set, figure out what is the problems in these data sets, and then solve it. And so for people who have some CS background, this is going to be like probably the easiest contest ever. Yeah. What do we do once we're done? Good question. So once you're done implementing all three models and you've gotten the results, we want you to identify which is the most accurate model, right? So which model has the highest number in terms of accuracy score, and then send us a DM on Zoom. We'll be monitoring the chat, and we can see who's correct. Oh, sorry, who's the winner? Sorry. Oh, you don't need to improve the accuracy. There's a question from the chat. You just need to fill in the blanks or fill in the missing pieces of the code. And okay, you need to also send us the accuracy details, the number in particular. Okay, this is very fast. We actually got a winner already. So Russell Serang got the winner. He identified the naive Bayes model as being the most accurate model with a figure of 85.7% of accuracy. Okay, he actually managed to run all three of these models. So he ran the naive Bayes model, the Conor SVM, and the SVM model. So we're just going to give some more time for everyone else to finish, so that if you guys have any questions, we can help you guys as well. But we have got a winner. So Russell Serang, if you would like to have a prize, you can send us your email on Telegram or on Zoom DM, and we will send the prize over. So maybe I'll go through the slides to sort of give you guys any hints, right? So for the first one is the support vector machine model. This is just the missing file name, so that you can key that in. What is the name of the missing method used in the prediction step? Keyword is the prediction step. So see if you guys are able to get that. And lastly, Conor SVM model. This is the third model, and also the most accurate model in this example. So if you remember from the earlier part of the workshop, I had gone through an example and I also shared the file. So you might be able to find the answers in the previous file. So again, if you guys run into any troubles, always send in the questions on Slido, and we'll be happy to answer them. And just to again share with you guys, if this photo will be available to you guys after this workshop, after today's workshop, and the recording of the Zoom meeting will be put up on the YouTube channel. So you can always check it out on your own time and experiment with these models. Okay, I think we have a question on Slido. For the person is asking, just now during the Kahoot competition, Kahoot quiz, it was said that the Conor SVM is the most accurate machine learning model for complex data sets, right? But based on the NLP competition just now, it seems like naive Bayes happens to be the faster model, right? Or the better model. So an important thing to note over here is that we're running it on a very small data set of like maybe about around 50 data points, I believe. And when you're running with a small data set, the issue is that your model is likely to show some bias in terms of the data set that it's been trained on, right? So chances are you're not going to be able to identify which is the most accurate model based on one implementation on one data set. So that is the reason for some of the discrepancy in terms of the Conor SVM being a more accurate model, but maybe showing some less accurate results in this contest. So yeah. But important thing about this whole thing is that about this whole contest is that you have three different models, but they all have their own sort of strengths and weaknesses. And when it comes to real life machine learning applications, not just in NLP but in other realms as well, it's about identifying, not just which model is the most accurate, but also what can you do to improve these models, or what sort of data set is your model's strength and what sort of data set is your model's weaknesses. All right, I think we'll wrap things up in about a couple of seconds, 30 seconds maybe. So if you guys, meanwhile, have any trouble, go to Slido. Okay, we have one more question from the Slido. Is the confusion matrix the only way to determine if the model is better than another model? So again, that is a very good question. So there are different metrics on analyzing your machine learning model's accuracy and maybe even its reliability or like its precision, right? And I guess the confusion matrix is a very is relatively easier to understand, and it gives you a lot of information as well, right? So it shows you, not just the accuracy, the percentage accuracy, but it also gives you a breakdown of where your model is going correct and where your model is going wrong. So if you look at the figure again, like the four numbers in the matrix, right? And then we have 64, 4, and some other numbers. Yep. Oh yeah. So you might find that using this model, you might be able to see if your model is perhaps being a optimistic model or a pessimistic model, and that allows you to actually adjust then different variables, maybe in your algorithm, or maybe just in the data set that your model is being trained on, to give it more negative examples so that it becomes less optimistic over time and thus more accurate in a general sense. So if you see that your model is making a lot of these false positive mistakes, that means it's predicting a lot of these things to be positive, but the output is actually negative. That is something that you consider the model to be an optimistic model. And likewise, for a model that makes a lot of negative predictions, you might consider that to be a more pessimistic model. And so again, if you look into the algorithm or the type of data that you're feeding your machine learning model through your training sets, you can make some adjustments there to make your model more neutral perhaps, and thus more accurate. So yeah, that's the reason why we chose to use the confusion matrix, because it is succinct and it offers you a very good understanding of your accuracy of your model. And I think with that, we'd like to wrap up the contest and the workshop. So congratulations once again to Russell, who has gotten back the result in a very quick time. So yeah, congrats. We'll be sending you the prize later on through your email. So look forward to that. And finally, just a quick comparison before we go. So these are the results for the different models that we run on. If you notice, the numbers are actually quite small. So the test set is actually a pretty small test set, right? So so these are the figures over here. It seems that your model, your Conor SVM model is giving a figure of 0.57. We have your SVM model with 0.71, and your naive Bayes model in this case appears to be the best. But once again, this is a small test set and a small data set. So the accuracy of the model might change with larger data sets or with more diverse data set. But yeah, for the sake of this contest, it seems like the naive Bayes model is the best or the quickest and most accurate model. So with that, we would like to wrap up the workshop. Again, thank you all for attending. Do check us out at DSC. This is our official website on the left, and you can check out our past workshops. And this current workshop will also be uploaded into the YouTube channel. So you can always check it out. And just before we go, if we could do one thing, which is to take a screenshot of everyone. I would love all of you guys to, I'd love it if all of you guys could turn on your camera so we could take a screenshot for our club. Don't be shy, we're just going to be taking it for our club's image. And yeah, we'll wait a while for. Yeah. All right, maybe a couple more seconds and we'll take a screenshot. All right, Sanyang, is it good to take? We're good to take a screenshot.
Right. Yeah. So, Jisnu, you are taking on your screen.
Yeah, sure. All right, I have it. So thanks everyone for attending. I hope you guys have learned something useful about natural language processing and about machine learning. And I hope to see you guys at the future workshops. So thanks for joining and have a great day.